Hello everyone, let's study fraction calculations today. Before we start that, let's have a brief revision on equivalence of fractions. When both numerator and denominator multiplied or divided by the same number, the number could be a whole number, a fraction, or any other type of number, even could be complete number when you study further. So fraction value remains the same, be unchanged. Okay? Let's see one example. 3/4 equals, so we choose number 4 times both numerator and denominator. So 4 here. The 3 times 4 equals 12. 4 times 4 equals 16. So that equals 12/16. We can also go back from here. So 12/16. If both numbers divided by 4, and 4 which is the largest common factor, then 12 divided by 4 becomes 3, and 16 divided by 4 becomes 4. So we can go back to be 3/4. Or if we don't choose 4, we can also choose another number, for example 5 here. So 3 times 5 equals 15, and 4 times 5 equals 20. So 3/4 also equals 15/20. If that's 6, then 3 times 6/4 times 6, that equals 18/24. Okay? So whatever the number is, it's always equivalence. Next is if we divide it by a number from the numerators and denominator. So here the example is 28/49. So we choose the largest common factor between 28 and 49, which is 7 here. So 28 divided by 7 is 4, and 49 divided by 7 is 7. So that equals 4/7. But alright, this can we'll do another example. For example, it's 12/48. So that equals, if you don't find the largest common factor here, you might choose any number you can find which is a common factor between 12 and 48. For example, we choose 2. So 12 divided by 2/48 divided by 2, which equals 6/8. So 12/48 equals 6/24. Okay? But you say 6/24 is not the simplest fraction here. Now we choose another number which is 6. So 6 divided by 6/24 divided by 6. So that equals 1/4. So 12/48 equals a quarter. So 12/8 is the equivalence of a quarter. We'll use this to calculate addition and subtraction for two fractions. You will see that later. So we finished the examples for numbers. We'll do examples for polynomials. So here a/b is a polynomial fraction. You can time any fractions or divide it by any polynomials or numbers, it doesn't matter. So here you say we choose a polynomial a. So a times a becomes a squared, and a times b, which is right, ab here. If we don't choose a, we choose b, then the top becomes ab and bottom becomes b squared. And we start from here, we choose another polynomial combination, CD here. So we times CD both top and bottom. That becomes ABCD over B squared CD. So basically, in theory, you can choose anything you like. It depends on what kind of questions you have. The next example, we simplify the prenumeral fractions. So left-hand side of the equation is a to the power a times b to the power 4 c cubed over a squared b cubed c. So let's find the largest common factor. Here, the largest common factor here for prenumeral a is a. For prenumeral b is b cubed. We always choose the lowest power for the prenumeral. So a here is 1, the lowest power for b is 3, and the lowest power for c is 1. So just c. That's the largest common factor for both the numerator and denominator. Let's divide it by that. To the top, no a, because a divided by a is 1. You don't have to write 1 here. You don't have to write. But b to the power 4 divided by b cubed, sorry, it shouldn't be b squared. No b squared, just b. Then c cubed divided by c here, which is c squared left. Let's see the bottom. So a squared b cubed c divided by a b cubed c here equals, just equal a, because b cubed cancel out, c cancel out, so a squared divided by a, just a here. So the final answer is b c squared over a. Okay, now let's start studying addition and subtraction of two fractions. So the point is, before you add or subtract, all or both the fractions must have the same denominator. If they don't, find the equivalence of fractions with the same denominator, then add subtract the numerators. So example 1 here. So 3 over 4 plus 5 over 16. Now 4 and 16 are not the same. So before you add, you must make sure they have the same denominator by finding the smallest common multiple. So what's the smallest common multiple between 4 and 16? So that's 16, because 16 is a multiple of 4. So for the first fraction, 3/4, equivalence must have the denominator 16. The 4 becomes 16 by multiplying 4. So 3 times 4 is 12. So 12 over 16 is the equivalence of 3/4. For the second fraction, 5 over 16 stay unchanged because it's already 16 in the denominator. Now, finally, you copy the denominator 16 at the bottom. You add the two numerators, because here is add, then you add. If minus, then you minus. So 12 plus 15, so 12 plus 5 is 17. Okay? If no further requirement to ask to give you a mixed fraction as a result, leave improper fraction implicitly. So leave improper fraction, because improper fraction usually is the one preferred. Okay? Remember, so 1/2 plus 1/3 never equals 2 over 5, because you add 1/3 to a half, you should get a larger number than a half, but 2 over 5 is smaller than a half. So the mistake is obvious here. So do not do that way. You never add numerator and add denominator. Make sure they have the same denominator. So next example is a half plus a third. The right way to calculate this. The smallest common multiple between 2 and 3 is 6. So a half becomes 3 over 6. So 2 times 3 equals 6. So 1 times 3 equals 3. Then plus 2 over 6. Now, you keep the same denominator 6. You add 3 and 2, which equals 5. So the final answer you will see is 5 over 6. Never 1/2. Sorry, never 2 over 5. Next example is subtraction of two fractions. So 2/3 take away 1/6. The first step is always change this to have the same denominator. So 3 becomes 6. So 2 over 3 becomes 4 over 6. Then minus 1 over 6, which stays the same. And you operate 4 minus 1, which is 3 on the top over 6. But you will always double check if the answer can be simplified or not. In this case, that can be simplified. So 3 over 6, you divide it by the largest common factor 3, that equals 1/2. So make sure you always leave the simplest form as your result. Otherwise, you may lose marks in the test. Okay, the other example is 7 over 9 minus 2 over 5. The smallest common multiple is just the product of 9 and 5 because they don't have the common factor. If two numbers don't have the common factor, the smallest common multiple just the product of the two numbers. Okay, you keep that in mind. The 9 becomes 45 by multiplying 5. So 7 times 5, which is 35. Then 2 times 9, so which is 18. So that becomes 35 over 45, take away 18 over 45. You just do the subtraction between two numerators, which is 35 minus 18 equals 17 here, and copy the 45 here. And the 17 is a prime number. You can't find any factor except 1. So that would be the simplest form as the final result. Now, let's see the prenumerals here. First example is a over b plus c over b squared. The two denominators here is b and b squared. The smallest common multiple here is just b squared. So the second fraction would remain the same, but the first fraction becomes something with denominator b squared. So b becomes b squared. That means b times b equals b squared. So the numerator has to be multiplied by b, which becomes ab. Then just simply add the numerators together. So ab plus c here over b squared. Next, so a over c minus b over d. So c and d doesn't have any common factor. So the lowest common multiple would be the product of CD, which is just CD, right? CD here. So C becomes CD, you times D. So A times D is AD. Then D times becomes CD times C, so BC on the top for the second fraction. So finally it becomes AD take away BC on the top over CD. So you find the additional subtraction of prenumeral fractions is not as hard as you thought. Okay. The next question, example, it appears to be complicated, but don't worry. Now follow me. AB squared over C squared D E cubed plus A squared B over C cubed D squared. It's obvious that the two denominators had something as a common factor. So the lowest common multiple won't be their product. Let's see the highest power for polynomial c here. So c squared is first denominator, c cubed in the second denominator. Then the highest one is 3. So c cubed would be the highest order. C cubed would be one part, the common multiple here. So you see, you write c cubed here. Then for d, the highest order is for d is 2. Then you write 2d squared. And the highest order for e is cubed. So you write e cubed here. Then c cubed d squared e cubed is the smallest common multiple. So how c squared d cubed becomes c cubed d squared e cubed? You simply times c and d, because c squared becomes c cubed times c, and d becomes d squared. D becomes d squared. You times d. So actually, you times cd for the numerator of the first fraction, then becomes ab squared cd. For the second one, and similarly, c cubed d squared e becomes c cubed d squared e cubed. The only difference here is e becomes e cubed. So you times e squared. For the second fraction, the numerator becomes a squared b e squared, because you times e squared. Then finally you add the two fractions, two numerators on the top and over the common denominator here. And finally you simplify that by factorizing the numerators. We find the common factor for the two terms in numerator, which is ab here. We put ab in front and followed by bracket. The first term divided by ab equals bcd, and the second term divided by ab equals ae squared. So for the last step factorization, you'd better do that, because you won't lose marks for that, but you may lose mark for result factorizing that. Read carefully about the requirements for the questions, and you decide if you do need factorization or not. Okay. Next, let's consider the multiplication of two fractions or more than two fractions. So that rule is simple. You don't have to do anything about finding the equivalence of two fractions. You just multiply numerators together and over the product of denominators, and finally simplify the result if possible. But I recommend you to simplify the result during your calculation, not at the end, because at the end you will find it's more complicated to simplify that. Example 1. 3 over 4 times 3 over 5. You simply times 3 and 3 here, and 4 times 5 for the denominator becomes 9 over 20. Okay, that's easy enough. Next question. So 9 over 4 times 7 over 3. So basically, some students will do 9 times 7 on the top over 4 times 3 at the bottom. Then you finally get 63 over 12. But 63 over 12 is not the simplest form. You have to simplify that. But some students have trouble with finding the largest common factor because they are not familiar with the timetable. Here, this question, the largest common factor is 3. So 63 divided by 3 is 21, and the 12 divided by 3 is 4. So the simplest form is 21 over 4. Okay? You won't find anything simpler than that, because 21 is an odd number, 4 is an even number, and they don't have any other common factors. That's it. But this one is not recommended. Okay, let's do it in a recommended way, in a quicker way. We simplify during the calculation. Okay, so 9 over 4 times 3 over 7. Basically, for multiplication, you can simplify the calculation from any top with any bottom. Here, when I say top means numerator and bottom means denominator. So 9 and 3, 1 is not one is on the top, the other is at the bottom. So 9 and 3 has a common factor 3. You can directly cancel simplify that. So you divide it by 3, 9 becomes 3. 3 divided by 3 becomes 1. So basically becomes 3 over 4 times 7 over 1. So that means 3 times 7 is 21, 4 times 1 is 4 here. So this one is recommended. I highly recommend it to do multiplication of fractions in this way. And similarly, another example is 15 over 7 times 28 over 9. Do not calculate 15 times 29 and then calculate 7 times 9. It will be more complicated. So 15 and 9 has the common factor 3. So both divided by 3, the top becomes 5. The bottom becomes 3. 7 and 28 has the largest common factor of 7. 7 becomes 1. 28 becomes 4. So that becomes 5 over 1 times 4 over 3 becomes 20 over 3. Okay, next. Our three fractions time together are basically the same. We can do it the same way. So that becomes, you choose 9 and 27, because 9 and 27 has the common factor 9. So that becomes 1, 27 becomes 3, both numbers divided by 9. And you choose 12 and 16, because one top and the other, choose the other one from bottom. So the common factor between 12 and 16, which is 4 divided by 4, 12 becomes 3. And 16 becomes 4. 5 and 25, similarly 5 becomes 1, 25 becomes 5. So you find the finally on the top, which is 1, 3, 1, you write 1 times 3 times 1 over 4 times 5 times 3, that equals, you find 3 and 3 cancel out again, so 1 over 20 is the final answer. If you do times 3 numerator together and 3 denominator together, probably it's hard to find the answer without calculator. At least it consumes a lot of time. Okay, so let's see next example. 4 fractions time together. We'll do the same way. So we simplified doing the calculation. Let's say 1449. So 14 and 49, the common factor is 7. So 14 divided by 7 becomes 2, 49 becomes 7. And 9 and 15 is 3, becomes 3, then becomes 5. Or 21 and 7 again. So 21 with this 7, so becomes 1, then becomes 3. Okay. You see, and this 3 and that 3, so 3, 3 becomes 1, becomes 1. Okay. Then 5 and 10 becomes 2, and becomes 1. Okay. And the 2 left here is 2. With these 2 cancel out, becomes 1 and 1. So finally you find the numbers on the top equals 1, 1, 1, 4. So 1 times 1 times 1 times 4, just simply write 4. But the bottom is 3, 1, 1, 1. So 3 times 1 times 1 times 1 again, just equals 3. So simply the answer is 4 over 3. It's much simpler than the way you calculate product of numerators and denominators. Okay. And let's see one example for the prenumerals. Let's say something on the left at the first equal sign. So ab cubed over c squared d times c cubed d squared over a squared b. So let's cancel out something between ab cubed and a squared b. So you find the common factor for a term is just a. So a cancel out, and a squared just becomes a. For b is b cancel out, and b cubed becomes b squared. And for c and d term, so c squared and c cubed just becomes c here, and d and d squared just becomes d. Okay. Then you will say the top the fraction that equal, you find the equivalence of this expression becomes b squared here over 1, because nothing on the left on the bottom of the first fraction, so that's here is 1. So b squared over 1 times cd over a. And then finally you find b squared cd over a as the final answer. It's easier, isn't it? Next, let's study the division of fraction. So when a number is divided by a fraction, you simply flip the fraction. So swap the numerator and denominator and change to a multiplication. So first flip the fraction and then change the multiplication. Remember, it's divided by a fraction. You only flip this fraction, okay? You never flip anything except this fraction. Examples here. 7 over 9 divided by 4 over 3. So every time you see a division, you must change to a multiplication and flip this fraction. So 4 over 3 becomes 3 over 4. Then you just simply do the multiplication as we did. So 3 and 9 cancel 3, become 3, that becomes 1, and becomes 7 over 3 times 1 quarter is 7 over 12. With that one equals 9 over 16, copy anything except the following fraction. So times 4 over 3. Then you 1, 4, 3, 1. Your final answer is 3 quarters. Okay. Another example is a fraction divided like 25 over 16 divided by a whole number 5. That equals, because whole number 5 means 5 over 1, so that becomes 25 over 16 times 1/5. So 5, 25, simplified as 5 and 1 here, so it's 5 over 16. Next, we'll do one examples for prenumerals here. So it appears to be complicated here. The first step will always change multiplication, change division to multiplication, and by flipping the numerator and denominator. Okay, so it becomes that one. And we'll do simplify doing the calculation. So AB term, we see the AB terms a squared b cubed for that one, and a cubed b squared here. The largest common factor for that is a squared b squared. So that divided by a squared b squared, just b left. That divided by a squared b squared, just a left. And similarly, the common factor for CD term is c squared d squared. So c squared d squared becomes d, and c squared d squared c squared. So the final one, okay, this is d, not a. It's b over d times c squared over a. So simply times b, numerator is bc squared over ad. That's the simplest form. Recommended. This way is recommended. Okay. Now, let's see some mixed type. That means you are asked the calculations, multiplication and division in one question. Now, remember that every time you see division, always change multiplication first. So that becomes 14 over 9 times what? It's 15 over 21. Then times 6 over 25. Then times 4 over 3. Now we simplify doing the calculation. We say 14 and 21 has a common factor 7. So 14 divided by 7 is 2. 21 divided by 7 is 3. 9 and 15 could be 3 and 5. Okay? And this 3 and 6 becomes 1 and 2. And this 5 and 25 becomes 1 and 5. Okay? So, in this case, you won't find any common factor between any top and any bottom. It finally becomes 2 times 1 times 2 times 4 on everything the top over 3 times 1 times 5 times 3. But in your calculation, you don't have right to write times 1 because it doesn't change any value of the anything of the value. But to show you clearly, I just write times 1. Then the top becomes 2 times 16 over 45. So 16 over 45 is the final answer. If you do simplify during the calculation, you don't have to do simplification after the final, after you get the result. Next example is, so 38 divided by over 25 divided by blah blah blah. So we change to multiplication first. 36 over 25 times 15 over 28 times 7 over 9 times 3 over 14. Okay. Now 36, we choose 36 and 9 because 9 is the largest common factor. We directly get a 1 that becomes 4. And 7 and 28, which becomes 4, that becomes 1. And 15 and 25 becomes 3, becomes 5. Okay? Up to now, we can't see any common factor between any of the top and any of the bottom. Oh no, because top 4 here and 4 here becomes 1 and 1. Alright? Now I don't think we can simplify anymore. The top becomes 1 times 3 times 1 times 3 times 1 times 3. The bottom becomes 5 times 1 times 1 times 14, which equals 3 times 3 is 9, 5 times 14, which is 70. So 9 over 70 is the final answer.